Composite materials are formed by combining two or more different materials. These materials have distinct properties. When combined, they create a new material that is stronger and lighter. This new material has the best properties of each original material. Composite materials are used in many different products. They are found in airplanes, cars, and even packaging. The use of composite materials is growing rapidly. This is because they offer many advantages over traditional materials. Composite materials are often lighter and stronger than traditional materials. They are also more resistant to corrosion and fatigue. This makes them ideal for use in demanding applications. The development of new composite materials is an ongoing process. Researchers are constantly working to improve the properties of composite materials. They are also working to develop new manufacturing processes. These processes will make it cheaper and easier to produce composite materials. The aerospace industry was one of the first to adopt composite materials. The use of composite materials in aircraft has increased significantly over the past few decades. This is because composite materials offer several advantages over traditional aircraft materials, such as aluminum. Composite materials are much lighter than aluminum. This reduced weight translates into significant fuel savings. A lighter aircraft requires less fuel to fly the same distance. Additionally, composite materials are stronger than aluminum. This means that aircraft can be built with fewer materials. One notable example of the use of composites in aerospace is the Boeing 787 Dreamliner. This aircraft is made primarily from composite materials. The use of composites has resulted in a significant reduction in weight compared to similar-sized aircraft. This has made the 787 one of the most fuel-efficient airliners in the world. The 787's composite structure also allows for higher cabin humidity. This enhances passenger comfort during long flights. The use of composite materials has been a key factor in the success of the Boeing 787. It has also paved the way for the increased use of composites in other aircraft programs. The automotive industry is another major user of composite materials. Composite materials are used in a wide variety of automotive components. These components include body panels, drive shafts, and suspension components. The use of composite materials in automobiles is driven by the need for lighter and more fuel-efficient vehicles. Composite materials offer several advantages over traditional automotive materials, such as steel. They are much lighter than steel. This weight reduction improves fuel efficiency. Lighter cars require less fuel to accelerate and maintain speed. A prime example of composite use in automobiles is the BMW i3 electric car. The i3 features a passenger cell made entirely from carbon fiber reinforced plastic, or CFRP. CFRP is a lightweight and extremely strong composite material. The use of CFRP in the i3 significantly reduces the vehicle's weight. This weight reduction improves the i3's range and performance. The i3's CFRP passenger cell is also incredibly safe. It provides exceptional protection to occupants in the event of a crash. The BMW i3 demonstrates how composite materials can enhance both the performance and safety of automobiles. Composite materials are increasingly used in packaging applications. They offer a unique combination of strength, lightweight, and barrier properties. These properties make them suitable for packaging a wide range of products. From food and beverages to electronics and pharmaceuticals, composite materials can be molded into complex shapes. This allows for innovative packaging designs. These designs can improve product protection and enhance shelf appeal. The lightweight nature of composite packaging also reduces transportation costs. This makes it an environmentally friendly option. One example of composite packaging is the use of PET bottles for carbonated beverages. PET, or polyethylene terephthalate, is a strong and lightweight plastic. It acts as a barrier to carbon dioxide. This prevents the beverage from going flat. PET bottles are also shatter-resistant. This makes them a safer alternative to glass bottles. The use of composite materials in packaging is expected to continue to grow. This is driven by the increasing demand for sustainable and high-performance packaging solutions. Composite materials are well positioned to meet these demands. Composite materials are also gaining popularity in the construction industry. They are used to reinforce existing structures, such as bridges and buildings. Composite materials can also be used to create entirely new structures with enhanced properties. One of the main advantages of composite materials in construction is their high strength-to-weight ratio. This means that they can add significant strength to a structure without adding a lot of weight. This is particularly important in applications where weight is a major concern, such as in earthquake-prone areas. A notable example of composite use in construction is the rehabilitation of the West Gate Bridge in Melbourne, Australia. The bridge was strengthened using carbon fiber reinforced polymer tendons. CFRP tendons are incredibly strong and lightweight. They were used to reinforce the bridge's existing structure. This extended the bridge's lifespan and improved its safety. The West Gate Bridge project demonstrated the effectiveness of composite materials in extending the life of aging infrastructure. It highlighted their potential for creating more resilient structures in the future. Section 6. Material Selection. Finding the perfect blend. Selecting the right composite material for a specific application is crucial. Engineers consider various factors when making this selection. These factors include the mechanical properties of the material, its resistance to environmental factors, and its cost. For example, an aircraft wing requires a material with high strength and stiffness. It also needs to be lightweight to maximize fuel efficiency. Carbon fiber reinforced polymer, or CFRP, is an excellent choice for this application. However, CFRP can be expensive. For applications where cost is a major concern, glass fiber reinforced polymer, or GFRP, might be a more suitable choice. GFRP is not as strong or stiff as CFRP, but it is significantly less expensive. The selection of the right composite material is a balancing act. Engineers must carefully weigh the various factors to make an informed decision. The manufacturing process for composite materials is another important consideration. Some composite materials are easier to manufacture than others. The manufacturing process can also impact the final properties of the material. Section 7. Benefits of composites. A winning combination. Composite materials offer a wide range of benefits over traditional materials. These benefits have led to their widespread adoption across numerous industries. Some of the key advantages of composite materials include lightweight. Composite materials are significantly lighter than traditional materials like steel and aluminum. This weight reduction translates into improved fuel efficiency in vehicles, increased payload capacity in aircraft, and reduced transportation costs for packaged goods. High strength. Despite their lightweight nature, composite materials exhibit exceptional strength. They can withstand high stresses and impacts, making them ideal for structural applications. This strength-to-weight ratio is significantly higher than that of traditional materials. Corrosion resistance. Composite materials are highly resistant to corrosion, unlike metals. This makes them suitable for use in harsh environments, such as marine applications or chemical processing plants. This resistance to corrosion contributes to their longevity and reduces maintenance requirements. Design flexibility. Composite materials can be easily molded into complex shapes. This design flexibility allows engineers to create innovative products with improved functionality and aesthetics. This is particularly beneficial in industries like aerospace and automotive, where aerodynamic designs are crucial. Durability. Composite materials have excellent fatigue resistance, meaning they can withstand repeated cycles of stress and strain without failure. This makes them suitable for applications where durability is paramount, such as wind turbine blades or sporting goods. Section 8. Challenges and considerations. Overcoming the obstacles. Despite their numerous advantages, composite materials also present some challenges. These challenges must be addressed to fully realize the potential of these materials. Some of the key challenges associated with composite materials include Cost composite materials can be more expensive to produce than traditional materials. The high cost of raw materials and specialized manufacturing processes contribute to this. However, ongoing research and development efforts are focused on developing more cost-effective manufacturing techniques. Repairs. Repairing damaged composite materials can be complex and time-consuming. Specialized techniques and trained personnel are often required. Unlike metals, which can be welded, repairing composite materials often involves patching or bonding techniques. Recycling composite materials can be challenging due to the different materials used in their construction. Separating these materials for recycling requires specialized processes, which are still under development. However, progress is being made in developing more efficient recycling methods for composite materials. Long-term performance. The long-term performance of composite materials in certain environments is still being studied. Factors like UV exposure and moisture absorption can affect their properties over time. Ongoing research is focused on improving the long-term durability of composite materials in various operating conditions. Section 9. Conclusion. Composites. Shaping the future. Composite materials have emerged as transformative materials across a wide range of industries. Their exceptional properties, such as lightweight, high strength, and corrosion resistance, offer significant advantages over traditional materials. From aerospace and automotive to construction and packaging, composite materials are enabling the development of innovative and high-performance products. While challenges remain, ongoing research and development efforts are focused on addressing these issues. As manufacturing processes become more efficient and cost-effective, the adoption of composite materials is expected to continue to grow. The future of composite materials is bright, and they are poised to play a pivotal role in shaping our world for years to come.